Welcome everyone. In this video lecture, we will solve a GATE 2025 EC question which is based on MOSFET based differential amplifier circuit. Okay, so this one is a numerical on MOSFET based differential amplifier circuit. So the question is the identical MOSFET M1 and M2 are in saturation and which is shown below. Okay, here this one is the two identical MOSFET M1 and M2 which are working in the saturation region, and the circuit is shown here where the RD1 RD2 resistance is 1 kilo ohm and M1 M2 resistance. In addition to that, the transconductance, the GM value of both the transistor M1 and M2 is given 5 millisiemens, and the input voltage signals, okay, is given V1 and V2 which is 2.5 plus 0.01 sin omega t and V2 2.5 minus 0.01 sin omega t. So we have to find the voltage V3. Okay, V3, this output voltage V3. So this output voltage V3 is a function of some DC component plus AC component that we have to find. So how to solve this type of problem? So first of all, from the question it is very clear that the given thing is our input voltages. Okay, so the given thing is this. I am writing here the given item, it is V1 V2 is given. Okay, and the transconductance value Gm for both the transistor, I am writing 1 and 2 for both the transistor is given 5 millisiemens. Okay, so we have to find this value of V3. Okay, so here two voltages are there, V1 and V2. Okay, so we can find first the differential input voltage. Okay, differential input voltage. Okay, so that differential input voltage we can write as VID, and this can be written as V1 minus V2. Okay, V1 minus V2. So here we have to find the first we have to find the gain. If we are able to find the differential gain, like for example I am saying AD, the differential gain for this type of differential amplifier is simply minus GM RD by 2. Okay, minus GM RD by 2, and this AD is also very similar. We can say like output voltage V3 by VID. Okay, is it clear or not? Means the formula that we will use, the differential gain of that particular differential amplifier MOSFET equals to minus GM RD by 2, and the differential gain AD is nothing but simply V3 by VID. So first we have to find, these are the two formula we can say we have to use. Okay, this is the very fundamental one. So in differential amplifier the gain is minus GM RD by 2. So first we have to find the value of VID, that is our differential voltage, differential input voltage. Okay, differential input voltage VID, V1 minus V2. So the value of VID we can write as, wait, I have to select pencil, then VID is simply V1 minus V2. Okay, so if we take V1 minus V2, so 2.5 will be cancelled, or I am writing full 2.1 sin omega t minus 2.5 minus 0.01 sin omega t. Okay, so these 2.5 will be cancelled. So the differential voltage VID value will be simply 0.01 and 0.01. Okay, so it should be 0.02 sin omega t. Okay, this one is the differential input voltage VID that we have already find. Okay, so now first we have to find the AC gain. This expression, say I am saying this one is equation number 1 and equation number 2. Okay, so this, from this expression what we can write, from we can say from equation 1, from equation 1. The differential gain AD value is minus GM RD by 2. Okay, so this value minus GM is 5 milli, so I am writing simply 5 into 10 to the power minus 3. RD value is 1 kilo ohm, so we can write 1 into 10 to the power 3 divided by 2. Okay, so AD value, this 10 to the power minus 3, it should be minus 5 by 2 minus 2.5. Okay, and this 2 minus 2.5 we have already calculated. Okay, so this AD is also be equals to minus 2.5, and this value is nothing but simply V3 by VID. Okay, so the AC component V3 value will be minus 2.5 into VID. Okay, minus 2.5 into VID, so it should be minus 2.5 into 0.02 sine omega t. So if we multiply, or you can do like this, 25 by 10, then 100, then what I will write, minus 50. Okay, 25 into 2, 50 by 1000. Okay, sine omega t, or it should be 0 cancel, minus 0.05. You can directly write also 0 point sine omega t. So the V3 value I am writing here. The V3 value minus 0.05 for the AC component we have find. Okay. Now we have to, this V3 have both AC and DC component. Okay, because we are signal giving AC and DC both. Okay, so now we have to find the DC component of V3. This one is our, we can write as AC component of V3. Now we have to find the DC component of V3. Okay, so DC component of V3 is very easy to find. How? See, this one is a IDSS, the current, total current is, and both the transistor in saturation and matched transistor. So we can say this current, I am saying IDS, and this current will be IDS. Okay, so this should be 1 milliampere, and this should be also 1 milliampere. Okay, means this one is our 2 milliampere, and both are meshed. So IDS we can write as, IDS is nothing but simply just divided by 2. So it should be 2 by 2. So we can write 1 milliampere each. So now this one is 1 milliampere, this current is almost 0. So this current is also 1 milliampere. Okay, so this V3 DC component. Okay, so I am just writing this diagram. Okay, so here what we are saying, this component is 1 milliampere, and this one is also 1 milliampere, and this DC component 1 milliampere. So we have to find this V3 DC component. So this component will be written as VDD minus, I am saying this one is a IDS, okay, minus IDS into RD1. So this should be 5 minus IDS is simply 1 milliampere, 1. This one is 1 milliampere current. So 1 into 10 to the power minus 3 into 1 into 10 to the power 3. This should be cancelled. So it should be 5 minus 1, 4 volt. So overall V3 component is nothing but simply V3 DC plus V3 AC component. So DC component is our 4, and AC component is our 0.05 minus, okay, minus 0.05 sine omega t. So our answer will be this V3 equals to 4 minus. So DC component is very easy to find. Okay, means VDD minus IDRD, or just I am writing IDS current. So IDS minus IDS into RD1. So 5 minus 1, 4 volt. So this DC component will be this one will be V3 will be 4 volt. Okay, this one will be 4 volt for DC component. Okay, and for the AC one, it is already given 4 minus 0.05 sine omega t. Okay, so it should be 4 minus 0.05, 4 minus 0.05 sine omega t. So this one is means, but we have to know this formula. You can easily derive this one. This formula, AD equals to minus GMRD by 2. So differential voltage we have to find VID, very simple this one. And then AD we have find minus 2.5. Now AD is nothing but simply V3 by VID. So now VID is known to us. So we can find the V3 DC AC component. This one is nothing but simply the AC component of this value which is coming here, minus 0.05 sin omega t. And the DC, for the DC component, simple, we have to use this 2 ampere will be 2 milliampere 1 and this will be VDD minus IDS RD1. So it will give the this one. So the correct answer will be 4 minus 0.05 sin omega t. So which one is the correct answer? The correct answer will be this one, 4 minus 0.05 sin omega t. So this one is the correct answer, you can say. Okay, but the thing is that we have to know the sum formula. In question it is very clearly mentioned the V1 value, V2 value. So VID we have find the transconductance, both are mesh transistor 5 millisiemens. So first we have find the gain, AC gain. AC gain AD minus GMRD by 2. Okay, then AD value now known to us, this one. Then AD is nothing but simply V3 by VID, output by differential input. Okay, so this one. Okay, then V3 we have find clearly minus 2.5 into VID. VID is known to us, this one. Then DC component, so 2 milliampere, so 1 milliampere, this current will be 0, gate current will be 0, DC component. So it should be 4 minus 0.05 sin omega t. So this is all about this question. So thank you for watching this video. Thank you.